Okay, what we have here is Brent and Shannon working on the car, ready for the test run. Over here we've got some guys working on the computer to download the code. Looks like they're switching the battery right now.
Don't have any trouble with that little bit black down the middle. I could give that another coat of white too.
All we're having trouble with is right there's transition. That's nothing you can do.
Okay.
You know what, sir?
Yeah.
No, I still don't think there's anything.
Okay. Here's my problem then. That's great.
Whoops. Okay, here we've got Chris selling t-shirts. He's going to give us a nice sales pitch. Come on, let's hear it. Ah, beautiful. Beautiful. You gotta buy it, huh? Yeah, okay, we'll move on. We're making Chris nervous. Here we've got, well, what do we have here? Come on, Shireen. Shireen, come on, what do we have? What are you doing?
What am I doing?
Yeah.
Explain what you're doing, Shireen.
I'm talking to Rob Arnold. Rob Arnold. Man.
Okay, here the sign says we have the web demo.
Take your license.
I think it lasts maybe
And here we have Chris in action, trying to sell a t-shirt.
So you're at least another 2 years. And I would.
Over there, you have Chris, and he's selling t-shirts.
I've already edited that part.
I'm editing again. I'm editing better.
Oh, Gretchen.
Okay.
No, he didn't talk to them
Oh, no
enough.
sale.
No
That's
sale.
Bad.
Bad.
It's bad.
Bad.
No commission for him.
There's
There we have
Dr.
Dr.
Pottinger.
Pottinger.
Dr. Pottinger, will you do the electric slide for us?
That's tonight.
I was thinking about that when I got home last night. That oh, thank goodness nobody had a camera there.
It's electric. Boogie, boogie, boogie.
Just wait. I'm keeping your camera tonight.
Don't
I know
worry.
better tonight.
Yeah, it's on.
That's what happens when you go to the hospitality suite here at the IEEE Region 5 Conference.
It is now about, what, 10 in the morning.
10 in the morning.
They're still passed out.
From the hospitality suite. Screwdrivers and beer and rum, and there's Dr. Ajar. He's over to our left here.
To your left.
Hello, Dr. Ajar. How are you?
Well, I'll be better when we win.
Dr. Ajar did not attend the hospitality suite. He is very pert and alive.
What do you mean hospitality? What was this?
Ooh, Dr. Ajar wanted to attend the hospitality suite.
I wasn't aware of it.
Yeah, they had. Well, he brought his band. I'm talking to the microphone.
The field is also underneath the wire here, and then it leaves.
When they park it on their car accidents, the field is no longer.
Oh, push it, yeah, no.
I think it's Shannon, you got the car ready to run around, so they don't have it's doing a little bit of troubleshooting.
Oh, no.
This next race, that's what's happening. This one, on this one, that one. Bet me, honey. There's no way we can stick one in work one with it's bad. There's two different devices in there. There's two instruments.
These devices are on that one. I think taking a better view.
Yeah,
I can't guarantee.
Can't do that. One-on-one more stuff.
I'm serious, man.
James, read it. I'm gonna call home and say if you're already taking out
whoops.
How did you get off? I don't know why you get off with
It's kind of a hard change, actually, the way it's designed. Maybe people have to make it. Then we'll use the other team. Or the judge. Well, he said it's an interpretation of the rules.
Does everybody know that we're going to have the captain's meeting at 1:30? All right, we said the contest is going to start at 1:30, so we'll give us maybe a couple more minutes for a trial run or whatever. But actually, since there's a small number of contestants that will do the captain's meeting at 1:30, last a couple minutes, and then we'll start right into the contest.
Happens there, we're going to pick for positions. There'll be four positions starting off. If both cars lose, they move down into the losers bracket, exactly the same positions they were in. The top car will still be on top of the bottom car in the losers bracket. And if just one car is eliminated, the other one progresses in the winners bracket, and only one car will go down into the losers bracket. Again, though, so there is the possibility in the losers bracket of a car actually not having to execute a race at that level and going to the next level without having to execute the race. We've got another option there, and that's the option that since every car has to complete the course to go to the next level, we could still have the option that even though there's not a car to race against it in that heat, we could still force the heat on that car. What do the captains feel of that? You'd rather see them force the heat or just progress to the next level by a chance of the draw?
Just to make sure that the car can do it again.
Everyone else that advances to the next level has to complete the course. In this case, we're allowing a car to go to the next level without completing the course. Because they're forcing us to go by completing the course. Everybody has to complete the course, so even though they're racing no one, they still have to complete the course to go to the next level. Fine.
In case two cars lose,
Yes.
and either, depending upon the fact that they didn't cross the line, or the time ran out, I think the judging should be done, the winner of those two should be done on how far they warmed up with respect to the other. As far as determining.
No, we're saying they both were. We're saying there is no winner.
The rules say something about if you leave the track, you're disqualified.
Yeah.
Right. If you don't finish, you're disqualified. In that case,
Does that count as a loss?
no, that means it's a loss. It means that's your first loss. It's not, you're not disqualified from the rest of them. You've got to lose 2 heats before you're out of this.
Now, we're allowed to stand right here and stop our car right as we cross the
You're
line,
allowed
right?
to stand back on this side. We still want to give the judges a clear view of what's happening. If you really don't want to touch it, I'd suggest you not even touch your car till it at least leaves the plywood.
Oh, we can't do that.
Can you?
It's good, it'll do damage to our sensors.
If we can hold our hand right here and stop it before it leaves the wood.
That's okay. That's okay. As long as you don't, it's give you about halfway to the finish line. From the end of the track, halfway to the finish line, you can put hands. As long as the judges, there'll be 2 judges over here on this side watching the finish line.
They don't want you to cross and get damaged, so you have to go off the edge.
Since the cars are carrying optical sensors, there'll be no flashes allowed. Let's just say no flashes at all, okay? Once we get to the part where the people are explaining how their cars work and they want to allow people to take pictures at that time, fine. But if you want to, later on after we're finished, if you want to take some demo pictures of your car, on the track, fine, okay? But during the contest, no flashes, no VCRs with lights attached to the VCR. Nothing that'll change the illumination.
I just made that announcement.
Okay. And there's
Flashes like that on the back end, as long as it's not by the doors? Is that you'd rather
Not while they were, not really.
Now, we also said if your car, if any part of the chassis of your car overlaps the edge of the track or a wheel leaves the track, your car is still in the race. As soon as any part of your car touches the floor, you're out of that heat. You've lost that. So that, it's a lot easier on the judges also, because if the judge has to say, well, gee, did it wing the edge or not? I'd much rather have the course be the judge and not the judge be the judge. Any, yes?
Where will the judges be located?
We're going to have 2 judges at the finish line. I'll be doing the starting at the start point, and probably have at least 1 or 2 of the two-lane students that helped put the track together and show up here at intermediate locations to sort of keep track of what's happening.
Is there any way you can extend the finish line, or because the judge will be able to sight down it? Because
it's not easy at this point. We thought about that 2 hours ago. I had a little bit more plywood.
But it does
chop some pieces.
extend out, correct?
Yeah. Oh, yeah. Oh, I misunderstood what you're saying. Yeah, we can't extend the track. The finish line is extended.
Okay.
An imaginary line that's an extension of that white line. I think the judges will be able to see that. We've seldom had races that were that. The judges can also say it was a tie. If it's really that close and they want to say it's a tie, well, it's a tie. Okay? That's another part. On a tie, we'll just rerun the heat to break the tie. Rerun the heat to break the tie. Were there any other items we discussed earlier that we say we still want to get a final decision?
I have one more question. We can change so we can make adjustments between races?
Yeah, let's set a time. We've got to get in 7 heats. 10 minutes between heats would give us like a little bit over an hour and 10 minutes. That's assuming there's only one car eliminated per heat. We've got to run 6 heats. If there are 2 eliminated, then that's 1 less heat. So let's at least take, say, a 10-minute break.
If both cars agree, though, you can go ahead and go if you want
yes,
to, I guess?
yes, there's no problem there at all. If both cars want to start earlier, but if the car can have as much as 10 minutes for repairs, but if you have problems and you don't get it repaired when your time's up for your next heat, you're disqualified. You lose that heat.
We've got until 5 o'clock, and we've got this room up even beyond that, but the published hours of the contest are 1:30 to 5.
Does anyone feel that they want more than 10 minutes? Does anyone feel that 10 minutes is not? Okay. So let's say when a heat is finished 10 minutes after, we're going to leave it up to the judges to decide whether enough time has elapsed to call it the end of that heat. And let them judge the condition of the car from their point of view. Okay. And we'll also let the teams throw in a towel. If you feel like you're at the point where you're ready to throw in the towel, we give you that. We give you that option. Okay.
There's somebody to draw. There's somebody to draw the.
Is there going to be a bye in the first round, I take it? No,
they're only 4 inches.
Oh, okay.
That goes in. That goes in. Right, that's the very first. Next one, please. It's A&M, Texas A&M. Texas Tech.
Let's just make sure that. One other announcement, when we start the second round, which is
Missouri Rob.
we're going to redraw the position, everything will be from scratch.
Okay.
Does anyone, last chance, anyone need more than, the 10 minutes between heats will start after the race is finished. After the race is finished, we'll start the 10 minutes. Does anyone have a timer to start?
I do.
Very good. Very good. Okay.
Can we get some power supplies? Like, so
So we're gonna actually do a stopwatch time?
No,
timer, okay, on 10, okay.
Alrighty.
Both ready?
Martin, what's wrong? Stop moving. Martin, are you trying to steer?
I think he's trying to go.
What happened?
We have 10 minutes till the next heat. Now, once the two cars are here and in position, we're going to start ahead. Here we go.
Cross.
That makes a difference on the heat.
Yeah. Okay, front on track 1, Missouri roll on track 2.
That's right. Anyone want to open the starting post? You want to go home? Know your car?
No problem. I just wanted to tell you that
Cross.
We're going to call it.
10.
We like to do dangerous
Yes, we're in Lewis bracket with A&M on track 1 and Texas Tech on track 2. That's right. I got the last one.
Cross.
LSU is in the losers bracket alone. LSU has to race the track on this next heat. Paul, to progress. Yes. Let's explain the next step to this so everyone will know. After LSU, if LSU does not complete the track, they will only got 2 cars remaining, Missouri Royal and Texas Tech, and they'll race on another. When LSU completes the track, then we said no team goes to the next level without executing the track. We'll go back to the top of the list. Missouri Royal races the track. 2 teams that reduce the track, race one another. We always go back down to the bottom, go to the next level, go to the race. And we still always go back. The losers racing losers, winners,
So at this point, LSU is running the course to advance to the next level.
They're both run twice. They're both in the same race. They both playing on this. Both teams not going to run. This is the top. That's not the way
The fact was they got out because they didn't finish the other team. We get them around straight to
If you're not a team member or in one of the LSU tournament, y'all could just back up a little bit. We're trying to have some people video the race. LSU is running the course by themselves now, part of the rules, so that each vehicle has to complete the course to advance to the next level. So that's what we're doing right now. No, but to go to the next level. Yeah, to go to the next level.
If they lose here, they can't finish it there.
Thank you. Appreciate it.
So Texas Tech versus LSU. Texas Tech on track. LSU on track.
I gotta get your
Now what do we have? We have two more? If we win this?
Yes, that's why we're trying to on. Anyone want a, why did you go? Anyone want a, start there?
Is that going to flash? No. Oh, okay.
Extreme situation.
That's it. That's it. That's it. No idea what happened to it.
Cross one. It's a shame. That would have been great, right?
Don't forget to
Watch the line.
Team captains?
We get team captains, please.
Team captain.
Since we have flags for all first, second, and third positions, Missouri Rolla will get the #1 flag. Since Texas Tech beat LSU in the losers bracket and went on to race Missouri Rolla, Texas Tech will get the second place flag and LSU will get the third place flag. All right. Congratulations. The teams a chance to explain their designs before we go into the second round. So we'll do that with the video. On. So why don't we give winners one first shot at explaining your. Yes, sure.
It's automatic.
Give each team a chance to make comments.
We're from the University of Missouri Rolla. We started with basic RC car. For the current sensing, we use a pair of coils. And for the white line, we use infrared sensors. The coils feed an amp, feed into an amp and amplify signal. And for a processor, we use a microprocessor with a basic stand 2, which is here. All the analog signal from the coil is converted to digital, and through the program uses logic to follow the current. And then on the white line, it uses fuzzy logic to compare the previous values and equation to keep it on the white line. We use a 9.6 battery for the wire, for the motor, and the processor uses 9 volts. Is there any questions?
How long did it take you to, when did you start? About rough estimate, how many man hours?
We started probably at the beginning of the semester.
It's like 11 pieces total. How many people were on your team?
Around 15 to 20. 13, 15.
It varied.
The main force was probably, showing up all the time every week, which anywhere from 5 to 7, I'd say.
How fast is the stamp run? How fast do your eyes? One matrix.
Who designed the three parts? We also have a most beautiful car contract.
This was done about 3 a.m. in the morning before we came here.
Thursday, 3 a.m. or Friday morning.
When did y'all get it working?
Yeah, when was the car functional?
About 1 o'clock today.
It worked in different forms. We had several different versions of the software that worked in varying degrees. And we were always tweaking the variables. So y'all had a working version for a month, 2 months?
We started 2 weeks. 2 weeks. We've had a working hardware version of 2 weeks. Had trouble with our amplifiers, but besides that it worked. And we've been playing with the program for the latter part of last week and then all day today. Anyone else?
Thank you very much.
All right, I'm Tony Davis. This is Dave Halstead. This is Russell Hamilton. And Rusty Harris is shading us. We work team of 4 from Texas Tech University on this car. This was our first car we developed. That was the prototype. We wanted to get our ideas together on a car and then progress on to the next.
Can you speak up a little bit? They're trying to hear out there.
Oh, sure. No problem. I'm called the loud one. Anyway, it's so we went with a Motorola 68 HC11 microcontroller and wrote the software and assembly. David designed the amplifiers for and wound the inductors for this with magnetic sensing. We used some optic infrared sensors on the bottom that were run into the microcontroller for optical sensing. And I wrote the software that ran it. Russell built the car from put the chassis together. It's just a racing car chassis that we could use. And then we had this done about a month and a half ago. And it's been a good car for a while. We can put a PID control algorithm in it and had a lot of fun. Any questions?
The circuits are mounted this way for obvious wind resistance problems.
Yes. Before today, we just had traction and wind resistance problems were our main things, but it's pretty much more slow today.
Any questions or anything?
Okay. Should we talk about our other car? The second?
Why don't we
do that later?
Why don't we do it later? Why don't we do the second so everyone can see the car run and then video discuss that?
All right, I guess. Can we make me talk?
Yes.
Okay. All right. Starting from my right here, we have Sanjay Nair. To my right, to my left, your right is Teresa Miller. To the left is Manjul Rai, and my name is Arthur David Harvey. And this is our car. It has been working for 31 hours, 32 hours. It's been functional. It's based on a Kyosho frame, more or less. Most of the parts are Kyosho. We chose our processor as an MC14 3150, which is a Motorola event-driven type processor, running 5 megahertz. We're using a typical RC throttle controller. We've got a little servo motor, which is typical stuff from RC system. The real brains, where most of the sensing gets done is right up here in the front. We have our 2 coils, and we use differential coils, just like the Texas Tech group does. We use 3 optical sensors. Right underneath here, you can't really see it, but there's our op-amp network that filters the input to the coils, and a comparator network that gives us our different magnitudes. Our optical sensors are fed directly into our microprocessor. Terry and Manjul did most all of the programming. Sanjay and I did put the hardware together. And we're glad to be here.
And if you're wondering about how long we've been working on this car, how long since we got these parts and built this car?
It's been
about 2 weeks.
Less than that, because the process has been the last 30 minutes.
Less than 2 weeks.
Got a quick question. Do y'all sample and then go? Is that what we're seeing?
No, actually, it's an event-driven system where
the processor is actually a super scalar processor with 3 processors, one that continually monitors the inputs, and as soon as anything changes, it passes on to the scheduler and another processor and handles the events as they come in.
The problem we were having with the processor and the motor was too fast.
Yes.
Earlier we were going
For our control algorithm.
For our control algorithm, it's too fast. Too fast.
In order to maintain control, we wrote an algorithm that basically starts and stops the car every half second.
And, yeah, that's basically it.
That's basically it. Any other questions?
You said that you spent 2 weeks from designing the whole car. Was that from planning to the end of construction, or did you do some planning before that?
We've had the specs for about a month, but we'd started with a different version of the car, and then things kind of got canceled on that. Our microprocessor burned up. Our first microprocessor was a little behavior, and it died on us. So in the middle of last week, we had to scrape up another microprocessor and learn how to use it, things like that. Any other questions?
We did that.
Thank you.
Okay, needless to say, we did not have the success that other teams had. It did work this morning for those of you who did not have the chance to see it this morning. Unlike every other team here, we did not use a processor system at all. The only programmable things we had was we had 2 PAL chips. One to basically detect the signal, or they would take the input coming from the antennas and let the car know that it's supposed to start. And the other PAL would take the input from the optical sensors in the antennas and tell it whether to steer left or steer right. We have 2 elongated coils underneath to differentiate where it is on as opposed to the current and steer accordingly. It is a proportional steering system, so if it's dead center, it won't move. If it moves slightly, it'll move slightly, or if it's way off, it'll steer accordingly. We have light sensors back here in the back on either side that will detect the transition zone, and then it will use the expanded lights up here to follow the white stripe.
Which does very well.
Yes, it does follow the white stripe very well, but we didn't need that part of the race. Any questions?
How long it takes you to do that?
We spent all semester on it with a team of 7 people.
Was that
For this afternoon, do you think you could get it back up?
We can try.
I thought working this morning. It worked good. Was that part of a senior design project?
4 or 5 project. It's our senior design project.
How many different ICs do you have on there?
We really haven't taken into account. We've got 9 different boards of the type used by our Radio Shack that we crammed onto this thing. I know it's kind of like a rat's nest, but more or less. Any other questions?
How long did it take you to wire?
It took a couple of days to get all the connectors put on, all the wires soldered, and then troubleshooting loose connections. And we've been doing that this morning. We had problems with loose connections.
Was there some specific reason you chose base recall instead of a microcontroller base?
It just seemed the most simplistic design for us. Most of the people in our design group were electronics-based design. I was the only computer engineering type, I think, in our group. So we did not have a broad base of any type of computer engineering, so we opted to go with this design.
Thanks.
Is anyone here from the Arkansas? Oh, I'm sorry. Would y'all like to say a few words about your design?
I don't have the car with me, but I can talk if you want.
Sure.
Where's my team? My name is Heath Bebausch. This is James Mashford and James Bryant. We're from the University of Arkansas, and we had a car that we've been working on all week, and we've had no. Oh, I don't know what this is doing. Can somebody look at that and see if we're on camera or not?
Yeah.
We've had no sleep for about 3 or 4 nights recently, and we were kind of working before we got here. We didn't think we had a chance of getting her around the track, but not much more than that. But we got here and put it on the track, and it seemed to work a lot better than we thought. So we thought we had a chance, and we turned around and we blew a chip up, and couldn't find that chip. And then we wanted to download another program to reprogram our microcontroller, because we had to slow it down a little bit, or actually we had to speed it up and slow it down in different spots. And the program that we loaded to the laptop, for some reason, didn't work when we got here, so we couldn't load that down.
It worked last night.
The basic design of ours, y'all notice, ours is a lot simpler than most people. I don't know if anybody saw it this morning. We put it back in the car, but it was only 3 very small Radio Shack boards. We had the microcontroller, we had 2 op amps that picked up our coils, and then we had a motor driver unit, plus the LED array. And as far as the white line, we did really well. It could go really fast. The clutch, we had to go a little bit slower. One of the main things different between our car and anybody else's here is everybody here is using a car that's driven steering, and our car did not use steering mechanisms as far as turning the wheels. We had a car that was driven by 2 separate motors, so we had to use pulse width modulation to control the speed of each motor. And that was the main difference between any of the cars I've seen here today and ours. And that's about it. Any questions? Do what? We use the AC11, the same thing. Do what now?
With OC1, OC2, and OC3 for your...
Actually, for pulse width modulation, you have to use OC2 and OC3 for your pulse width modulation, and that worked great. Did real good, and that's the chip that drives is an H driver to control the motor, because like I said, the AC11 will put out 5 volts. We had to drive our motors at 12 volts, so we had a driver to drive the motors, and that driver is one that went out. We actually had 2 drivers, one worked one wheel, one worked the other, so we had half a driver on both of them that was working this morning. Wasn't quite good enough to make it work though. But no more questions, or any more questions?
It had 6 wheels, right?
Yeah, it had 6 wheels.
It all...
2 drivers.
2 drivers. Just the 2 middle wheels is all the time.
2 separate motors, too. Each wheel had 2 center wheels had a motor.
And we originally had our 2 coils in the middle of the car, because we had all the LEDs up top, and we were kind of limited for space. Ours is 12 inches long, exactly. So at first we had them under there, but we had to go back and mount the 2 coils with the LEDs right up front and kind of cram in there, because when we put them right by the motors, since ours are 2 wheel driving force, when we compensated, we compensated right there, and it threw us off too much. We didn't have any leeway at all. But anything else? All right, thank you.
You and the plaintiff, end of this. Sure. I appreciate it. I would also like a few minutes to introduce my Tulane students that helped get this track here, and if y'all have any questions on the construction of the track itself, signal generated, perhaps some of the other teams might give you some ideas also on what they used when they built their practice track, which is also a major part of this.
Thank you, Paul. My name is Richard Miller. I'm the chairman of the robotics contest for Region 5. This was our first contest, and really thrilled at the participation and interest. I'm from the New Orleans section. This is a contest that was actually that we brought over from Region 3. They hold it at their student conference called Southeast Con, and we've had up to 35 to 40 participants in some of these contests. It's really exciting. We hope you go back, share what you've seen here today, and just try and help us grow this contest. It's a tremendous educational opportunity, and it's just a lot of fun. So I want to thank everybody for their participation and interest. Other committee members are Don Preston from the New Orleans section, Ken Hemel from the Baton Rouge section, Brad Weber from the Baton Rouge section, Dr. Duvasan, Paul Duvasan from Tulane, Perry Morgan from Tulane, Lonnie Orth from Tulane. These three people here in particular, the logistics of building this track and hauling it from New Orleans up to Kansas City was a little bit of a challenge. Normally what happens, the host city and the student chapter are chapters that are involved. They're actually the ones that do everything from come up with the rules to build the track, and they will administer the contest. I realize we're not to that point along in Region 5 yet, but that would be the ultimate goal as we envision the contest. So that's just a little bit more background. And I want to personally thank all the committee and again all the participation and interest.
Any questions on the track itself?
You do plan on definitely continuing the contest each year?
Yes, absolutely. We have some preliminary rules for 97 already. We've talked with Zafar Taqui, the student chair, and there is some discussion as to how these next year's rules are going to actually officially be presented to the various student branches. But we do at least have actually it's a final set of rules. I don't know administratively if they're going to be tweaked or just how Zaf is going to actually handle that. But you know, I got the rules out late. You know, that's my responsibility. I take full responsibility for that. I realize that it puts some of y'all in some very short, you know, windows for design. Startup is a pain in the neck, and we do have 97 rules. If they're not actually handed out at the conference before you all leave, they will be very shortly thereafter. Give everybody a whole year or so to work on their project.
I understand that the length of the room is a problem when designing this track.
Well,
is it possible to have an area that the cars can accelerate a little bit to see how they will take the curve afterwards? That was when we were designing the car. That was one of the worries that we had, that on a straight path that we will accelerate so much that when we realize it's a curve, it will go out of the track. And we realized that although our car has capable of having variable speed, we realized that the speed along this curve was always constant for us. So we didn't use that feature of changing the speed in the car. I don't know if it helped us to win or not, but eventually, you know, that is what happened. The constant speed is what we have on this track.
I don't know that either. I'm going to have to defer to Dr. Dubuisson on that.
One idea of the optimal situation is, first of all, to have a very large location. You see today, it's very hard to get observers. And in Region 3, we've often had a major ballroom. When we did this in New Orleans, we had this track, we had 40 feet of track, which there was some relatively straight sections. There were some higher speeds, as you mentioned. You also can make the other mistake, and that is not to use the worst case radius of curvature. You want to make sure you also have some parts where the students have designed for a bad curve, and they can at least afford to handle that worst case. So we have a lot. This is what was left over in my attic from the 1980s. If it hadn't been in my attic, they may not have been. Another item is, when we did this in Baldwin, we often had bleachers on each side of the track. But that is an option, with a big scoreboard so everybody can know where they were, loser bracket, winner bracket. And I think that's what we would like to see eventually happen in Region 5.
When y'all was testing, did y'all have problems when you sped up on straightaways?
Yeah, we did test all day.
Yeah, our test track, we did have a straight line, and then we would go.
And then y'all turned y'all 3-foot curve radius?
Yeah, and we also designed for sharper curves, just to make sure that it would work on 3-foot radius.
So y'all didn't have any problem going at your sped up, or is that what you're saying, you had problems on that?
Well, with our track at home, we had a multi-speed system. It would, in straight stretches, if it went into a straight stretch and say that loud, it would speed up. Once we got here, we realized that wouldn't work. The straightest part is right there.
Right.
So a constant speed worked the best.
Okay.
And so that way we weren't speeding up just to go into a curve and then gain us in.
Our 40-foot track has some sections. Still, we had to use this modular construction, roughly 4x4 pieces that would trim so that we could pack this stuff away, pack it in a van, put it in a closet at a hotel, get it up to 15th floor of a hotel. Those kind of logistics were part of the design. We did have one 4-foot section that had a very short zigzag in it, so it was almost straight. The car would really pick up speed in that really short zigzag. And it usually followed the straightaway at the transition region, and it did get to some fairly high speed. But that was probably followed by a hard curve.
You say you were at the Region 3. How do the cars here today compare to the ones that are there?
You've got to realize Region 3 had like about a 15-year history of doing hardware contests prior to that race. It's one reason why we had 40 entries. We had some very fast cars in that race, but although reliability was the ability to execute the course reliably is also a major factor. And the luck of the draw in a big race can have a lot to do with it.
Paul, have you considered the slotted tracks with the indications and sensors as you pass on through the track with multiple routing? I've seen some of the designs in the Micro Mouse contest, and I think I'm going to pass on to the committee with the other designs. We need to start looking at maybe some other options which probably will bring in the other aspects of robotics, like multiple sensing and of course kinematics and controls. We need to also look at the control design, how they are doing it, and some other aspects of it. The demonstration, I think, is great. The work has done, a lot of work has done in it, and students have done a great job. But we need to look at some other options which will give them a little bit more technical knowledge and technical expertise in this.
Staff, may I address that? They've used other techniques other than just races. For instance, I can think of a case where they had like a pool table, and the object was for this robot to go get some balls and grab some balls here and go to a certain pocket and place the ball in that pocket and go back to home base. And the students probably do a better job of explaining this than I do. But that type of thing has been done before. You know, this isn't the only type of.
One of the things they have evolved to, and I use that word evolved because that's where they are. I mean, they've been doing this for 20 years basically now. The students knew a basic concept of what was trying to be accomplished, but when they got to the contest, their microprocessor was sent a command or a program was transferred into their microprocessor that it had to execute for their particular task. Not any two vehicles had the same task. They were judged on the ability to execute the program that was put in their car when they got there, and it involved a lot more dimensions than just racing on the track. But
the reason I was saying is I attended a similar thing in Tsukuba City, Japan, and I got a movie on that. There were undergraduate students competing on a similar type of thing, and they had a design. They had the slotted tracks, and on the way they had the sensors that their IR sensor on their robots would be sensing, and then there were multiple options for them to go, and they had specified that you should be able to go through so many slots and come back to the destination. It was a different design, and it helped the students also to really do the option, you know. So my point is,
how mature was that contest, Al?
2 years ago.
No, how mature? How long had they been doing it? Is that like a 15-year?
No, it was. I don't know how long they were doing, but that was they did it in 2 semesters.
I just, we tried to make this contest straightforward, just trying not to frustrate and introduce and build participation in the beginning. And believe me, Dave, I've seen some very, very complicated contests. We can, get any specification that we want.
There's one item that you must consider. Number one, you must consider who's going to be responsible next year to build the track. The more complicated you make that track, the harder you make it on the builders of the track, the harder you make it on the students that are going to participate. The thing that I feel is crucial is to get a lot of student participation, to get some students turned on to the idea of a robotics contest. If you do not succeed in doing that, you will not have a robotics contest. That is the number one item.
One point that's happened a little bit in Region 3 is that the cost of building these cars has gotten out of hand for some people, and its resources have become a problem too.
Yeah, as probably you all know that IEEE is encouraging, at least the student group, they are encouraging going into the computer science, and also the people with multiple disciplines in robotics, they are in the mechanical engineering department, encourage them to be part of IEEE group so that when you set up a robotic devices team, you have people from computer science, mechanical engineering, electrical engineering working together. Also looking at all aspects of robotics, which is your sensors, controllers, mechanical aspects.
Fuzzy control on that. So it's pretty good. I don't know if it's control or what.
Okay, let's go down the track. Again, no flash. Do you want? Did we pick positions again? Are you satisfied with this?
Just fine.
Yeah, well, this is not as good. It's just demo.
Turn on the
Turn on the
meeting on order.
Yeah, we gotta do it again. The one that didn't work.
You've been calling it
No, it is right here. There was only one car with having a computer in it. It was the worst performance. It was a PID control or something. With no computers.
No flash. The batteries aren't dead, you're gonna win. It's all strategy. You run out of battery. You go.
Yeah, but we already have Yes. Yeah, let's go. You missed it. It takes a lot for that one. That's delayed. The track is small enough so the delays are pretty good.
Increase the gain, huh? I can't. These guys are gonna have to step back just a little bit.
They need to move back a little bit for this car.
Thank you.
Wow, this is a cool thing.
Two small inductors and two small optical sensors, infrared optical sensors. And it simply decides which was the side it last saw the line on, and it moves the stepper motor in that direction. And it's very simple. We're just going back and forth with the stepper motor, and we have a potentiometer on the stepper motor, telling us where we are. and feeds back into AV for the AC11, which is controlling the whole operation. From there, it feeds into a lookup cable to linearize all this crazy data. We've got an on-linear pod and curving and all this stuff. We linearize all that into 90 discrete positions in front of the car, about 10 inches in front of the car, which we can tell where the line is. We just run that into the PID algorithm and steer the car with that. And it's fairly simple. It really simplified a lot of code. It really complicated a lot of hardware. We had troubles with the stepper motor, weight of the arm, position of the arm, everything. We had problems with everything is pretty much the same. But again, this was just a team of 4 of us in a last. So we've been working on this particular car for about a month.
We actually put it together
about a week of circuit construction and program design. So the chassis, David built this chassis. We bought an RC car and just took pieces of old circuit board, sanded them off, cut them in shape, and put them together. I think everybody should build cars like this, except faster.
Smiling faces. So we've got a lot of smiling faces to see tonight. I wanted to start off, my job is to do some of the introductions of some of the dignitaries that we have here. And before I do that, before I introduce Tom Keene and Chuck Alexander, are 2 of the 3 Ps that we have with us. I wanted to make a comment about Chuck, and wondered if anybody else had noticed this. Chuck used to be a pretty relaxed guy before he was elected president-elect. And he would show up at PACE conferences, so he'd be wearing shorts and t-shirts and things like that. But since he's been elected, I haven't seen him in anything but a suit. And I don't know if anybody else was looking at orange, but I think I figured it out. Did you notice he wasn't really wearing any clothes? He has a suit tattooed on him. The IEEE paid for that, actually, with the traveling and the presentations that they have to make. It's really cost savings. They don't have to check that extra bag. They can always carry on that way. And he's always got, just jump in the shower and clothes are clean. So, take a look and see if you don't agree with me. So, anyhow, we were fortunate enough to have 2 of our 3 Ps, the Ps being the president, the past president, and the president-elect. And I'd like to have Tom Keene, our past president of IEEE, stand. Tom's the one with the relaxed expression on his face. And Chuck, if you can stand up, he's the one with the real pain. And that's probably what in industry would be called a career-limiting move. So I just, you can't fire me though. Other guests that we have with us, Steve Unger, who is the director of Division 6. Steve is our representative from the technical activities side here. Tad sends a representative. He's trying to help bridge some of the differences, explain the differences between the technical activities and regional activities. We also have, I have to say, I'm not going to introduce Bob Alden, who's a dignitary, because somebody else is going to introduce him, but he's a dignitary also. I have some other introductions, and the reason for these introductions is that these are the people who are running for director-elect for Region 5. So you want to get to know these faces and get a chance.
My name is Jerry Herman, and we're here from St. Louis, Missouri to present a couple of MOCON awards standing for Missouri Conference Awards. I'm going to have Jim Leonard present the first award for higher members.
Thank you, Jerry. This is our MOCON rotating award for sections. This year it goes to the Denver section. As David Richmond here.
The next award is a new award that we're awarding this year for the first time. It's going to go to the student branch. This particular student branch in '93 increased from 375 members to 468 in '94. In '95, it increased to 566. This particular section probably knows who I'm talking about at this time. There was a total increase of student members from 375, 191. Today's total of 566. This goes to Student Branch, University of Texas, Austin, for '95. In attendance here is Bruce Williams, the section chair. Bruce, we don't want you to go too far. We're going to call you back. In addition to that, this is the first monetary award that we're given also for the University of Texas, a check here for $100. So they can call their members that really participated and have a good pizza and beverage party.
Thank you, Jerry. Next, we'd like to have Zafar Takfi, who is our Region 5 Student Activities Chairman. Zafar?
Thank you very much, George. Ladies and gentlemen, we had this year student activities has increased. We have 5 contests and 3 of them we're going to honor, and we're going to give the awards to the 3 categories. I'll be helped by the local student activities chairman, Jack Sibyl. Down here. All right, the first one is the design contest, and I'd like to have all the teams that participated in the design contest come forward.
I'll tell you a pretty dramatic story about what happened in the design contest today. These group of about 24 teams saved you all from thermonuclear war. And the really, really amazing part is they did it while sitting on a lab stool for about 8 hours. Really, we had a great group of people attending today in the design contest. We simulated an episode from the movie Crimson Tide, where the radio broke on a nuclear submarine and the students were forced in 8 hours to recreate the radio system to receive the code from the President of the United States. I think we had a lot of fun. People said they learned a lot, and I think everybody's going back with a new appreciation of some skills they learned today. I'd like to suggest we give them all a round of applause for their hard work. Very, very close competition. I stayed until almost 6:30 helping the judges finish up the judging. We have certificates to provide to all of you. So as we wrap this up, I'll file out, and I'd like to recognize the top 4 finishers in the contest. We struggled and struggled and struggled. Originally we had 3 positions, but we decided to expand it to 4 due to a tie. In 3rd place, the team from University of Texas at Arlington and the University of Oklahoma. Now, because of the tie, they're going to have to share their toys until we can get bigger ones for them.
I'll send your packages in the mail, guys. Congratulations. Second place, a local favorite, the team from DeVry Institute of Technology, Kansas City. Did they not? All right. Thank you very much, guys. And in first place, a handy digital multimeter because they didn't get enough of them today. The team from Texas Tech. Okay, thanks all to everybody. It was a great contest. We'll get some tickets to you down at this end of the floor. Thanks, guys.
Helping Jack, we had 3 judges. They are in your program, and if they are here, I'd like them to stand up and be recognized. Mr. George Brown, Mr. Bill Hagan, and Mr. John Manning. Now I'd like to tell that we had at 9 o'clock the students' forum, and students are wondering whether we're going to have the forum. Yes, we're going to have the forum immediately after this banquet. Richard?
Okay right now. Get the plug in.
May I have all the individuals who participated in the special robotic devices contest come forward. The reason I'm doing it because I want to save you time. Let everyone come here, all the teams that participated, have in groups. 1, 2, 3, 4, 5. This is something new for Region 5. Region 5 had not done the robotic devices contest, and I have to admit we found that Region 3 was doing a good job, and we imported some people last year from New Orleans area, several sections and branches. When they became part of Region 5, we found that they were doing something that we had not been doing, so we gave the responsibility to all those experts. And what we see is something really very practical, and what they have done, very nice. What we had was a robotic devices contest, and let me first recognize the judges who participated, who helped in this. In charge of this project was Richard Miller. He was coordinator of this. And the judges who helped, Don Preston, please stand, all of you, and then we have the and Paul call him Paul because I have difficulty pronouncing his real name. And of course, Richard Miller. So I appreciate the judges for their work. First, let me give two special awards or certificates. And there were a couple of people who really worked very, very hard. Special certificate to Perry Hogan and Lonnie Orr. These are the students who worked with Paul in really helping the contest as a contest assistants. There were five teams, and they're quite a big group here. And so I'll read the names. The group, one group had entry called Tarkhan 1 from Texas Tech. The team had a captain, David Al Esteter, Tony Davis, Russell Hamilton, Rusty Harris. The team of 4, their entry was Tarkhan 1. And this is the certificate with that group. Look at that group. So group, the entry was called The Guide, and it was Louisiana State University. The team members were Sanjay Nair, Arthur Harvey, Manju Rai, Terry Miller, and Steve Greer. Another entry was from Texas A&M. The entry was a Smart Racer, and the team players were Martin Andrepon, Jason Myers, John Craig, Casey, Michelle Mazurowski, James Krolski, and Adam Wagner. I have killed the names most of them. From Texas A&M. The entry from University of Missouri, Raleigh, the Fuzzy Racer. And they had 2 captains, Brent Humphreys, Shannon Knopflin, Tim Shepardson, Brian Willingham, Christy Aga, Eric Hirsch, and Jeff Podass. Funny Racer. I don't know how many of you can pronounce my name. 30% only. You can't pronounce my name properly. So.
Zaffer, it's no problem.
But that's not it.
Hog Racer was the entry from University of Arkansas, and their team captain was Heath DeBow, James Mashburn, James Bryant, and Clinton Gibson. Now, looks like while we had the executive meeting here, and we had a big meeting of SPAC, you could see on the 2 monitors there was a big gang here, at least about 40-45 people cheering the racers in the room, Saloon D, and judges had real difficult time to judge and decide who the 3 winners are. And I'd like to have John come over here, John Reiner. The third place winner for the robotic devices contest goes to Louisiana State University. The second prize winner for this contest is entitled CarCon 1 Texas Tech. And the big trophy, I don't know who's going to pay for this, but anyway, the big one, number 1, entitled Fuzzy Racer, goes to University of Missouri, Rolla. And let's give once again a round of applause to the judges, to the One other big contest we had that started back in November and December was undergraduate paper contest. And these individuals started working from the branch level, section level, area level, and each area sent 3 representatives, first, second, third of the area. They won $50, $30, and $20 at area level. And here there were 12 entries. They had their technical paper and oral presentation. The paper contest judges, if they are here, I'd like to request them to stand up and be recognized. Jack Husson, Bob McCabe, Bob Grove, Peter May, and Dave Skidden. There were, instead of 12, there was 1 dropout. We had only 11 presenters this morning. A very, very polished presentation we had. I'd like to invite all the 11 presenters. Please come down here. Let me first recognize the individuals who participated in this. And Shane Haas, University of Kansas, North area. Last name there. Joshua Irish, North area, Southern Illinois University. Patrick Chapman, University of Missouri at Rolla, North. Stephen M. LaCombe, University of Denver, West area. Merit Rano, Colorado State University, West. Tim Home, Texas Tech University, West area. Alex F. Schmidt, Tulane University East. Aaron Elliott Jr., University of New Orleans, East area. Eva F. Tulane University. Preston Young, University of Texas at Arlington, South. And Zulema Bellew, Texas A&M, South. One paper had joint author, and the author didn't come, was not well this morning. All right. Okay. This is special because this has money in it. Okay. The third prize, we have three prizes. The third one is $150. The second prize is $350, and the top prize is $500. Okay. Should I open the envelope? The third prize winner is for $150, Preston Young, University of Texas, Arlington, for his paper, Fabrication of Non-Uniform Waveguide Gratings for Photonically Switchable Antennas. Now we have got your social security number, you have to include in the tax. The second paper, the second prize, we have the author, the title is Microwave Non-Destructive Surface Crack Detection and Tip Location in Metals. There are two authors, and so we have to split $350 in two, and the winners are Emerit Ranu and Robert J. Runser. The winner for the big prize is, well, let me first read what this paper is. pH control of microalgae using simulated power plant flue gas. From University of Denver, Stephen M. The second prize winners were from Colorado State University. So when you sum it up, we have two winners from West and two papers, one first and second from West, and the third is from South. My congratulations to all of you. I understand that the presentations were really great. Thank you very much. This concludes the students' papers. I'd like to really urge that the students, they should come to the forum immediately after the banquet.
Thank you, Souther. You did a good job pronouncing all those hard, difficult names. I want to also say that this afternoon there was an SPAC put on by the University of Kansas student branch, and we presented them a plaque for their department for putting on the SPAC, and also a certificate to Bob Campanini for being chairman of the SPAC. Did a good job. We have some Region 5 awards, and Ross Anderson, our past director, has a couple of items that he would like to pass to some of the sections.
Each year, the Regional Activities Board awards several awards for particular sections. One of those awards is the Section Sustained Growth Award for the section that has maintained for 3 years the best record of growth in the entire regional activities. That's the entire world we're talking about. The winner of this is in Region 5. The 1994 recipient of the Section Sustained Growth Award is the Central Texas section. We have two sections that are recognizing or achieving a milestone in their history. And this is a 50-year time frame in which they have been in existence for 50 years.
People with me at a table at lunchtime will just have to hear it again. But the preacher was preaching in South Louisiana, and part of his sermon was that the solutions to everything is in the Bible. And people should really read the Bible and find where everything is covered in the Bible. And in the back of the gathering area, a gentleman by the name of Woodrow, that's with an X on the end, raised his hand and said, excuse me? Preacher says, yes, sir. He said, are you telling me that, I think what he actually says, man, are you telling me that everything is in the Bible? And the preacher said, yes, sir, if I understood you right, everything is in the Bible. What do you have in mind? He said, well, I was wondering if y'all got PMS covered in that Bible. Preacher starts going through the pages and he says, oh, yes, my son. He said, I found it right here. It's in Luke. He says, it says right here in chapter 2 that Mary rode Joseph's ass all the way to Bethlehem.